It's time to take a look at how I'm going to organize my build scripts for this code base. For this arc, I'm going to do things a bit differently. Rather than writing all of this code from scratch like I've done previously, what I'm going to do is migrate this code over from another code base that has a similar system to the one I want. And I have a few reasons that I think this is a good idea this time. For one thing, this is what I would actually do just in this situation. If I wasn't trying to make videos, I wouldn't even think twice about it. This is exactly the path I would take. So it's, to me, very often useful to sort of have snippets of code that I'm moving around between my code bases and sort of leveling them up as I work on them. They're sort of small, isolated pieces. They're not deeply entwined in everything else, but they're useful. They do some work, and when I need them in another place, I can just copy them over. I don't have to, build it from scratch, which can take a lot longer. And as I'm doing that copying, I can take advantage of the fact that it's going to only live in this new context, so I can adapt it to the things that the new context will need. So in this case, for instance, I'm going to be able to fit it to the paths system that the current code base is structured with, which is a little different than the context that I'm copying from. And then, of course, every time I copy it, I also get a chance to iterate on it again and upgrade it a little bit more so that it gets more and more refined. And, maybe someday one of these snippets can go off and live on its own in a fully finished sort of system that doesn't need more iteration. Although, who's to say it doesn't need more iteration? Maybe it could always get a little better. But point is, it gives me an opportunity to upgrade the thing I've got every time I copy paste it to a new place and put a little bit more time into it. Another reason I thought it would be useful is that it gives me a chance to demonstrate how I do code copy pasting, which I don't think I see a lot of places where there are tips on how to do a good job of reusing code by copying and pasting it, but it's a useful thing to know how to do if you've got some code that you want to move into another context and copy pasting is the way you're going to do it. That doesn't have to be a bad thing if you have a idea of how to do a good job with it. So I'm going to use this as an opportunity to demonstrate how I do this. And then the final reason I have is that this particular system is one I've been iterating on a lot recently. And so doing it this way gives me just another opportunity to iterate on this particular system and get it a little bit closer to maybe being a final, fully isolated thing that I don't copy paste around and modify, but just is its own thing. But it's not quite there yet. So this will be an opportunity to upgrade this snippet while we're integrating it into this code base. So let's get started. While that's getting started, I'm going to explain the choice of language for this build system. So for one thing, I want to avoid having multiple scripts for the same piece of workflow in different contexts. And what I mean is I don't want to have like a bash script or a shell script in Linux and then a batch script over on Windows where I have to keep them kind of in line and so that they do the same thing in like totally different languages and only have the ability to test them whenever I'm switching back and forth. It leads to one of them always just getting out of date and broken, and then the day comes to ship a piece of software and you have to go fix all the build scripts that are falling behind. That's a bad situation. I don't like it. So I want my scripts to work correctly everywhere. And then on the other hand, I don't want to have to install lots of other extra tools. I don't want to have to, if I use Python or Make, which might be good tools, but the problem is just if I can avoid installing an extra tool for my build, then that's just a little bit better. It's a little bit easier to set up a new computer to do work on this code base when I need a transfer, which it always comes eventually on a code base that lives a long time. Either new people get involved or a new machine gets involved and you have to transfer, and the less tools there are to set up, the quicker you are done with the tedious setup part. So if I can avoid having to install extra things and set up the right versions of different tools and environment variables, that makes me happy. So I want to get both of those, but they're kind of at odds with each other, right? Because the easy way to avoid extra installs is to just use the operating system's built-in shell scripting stuff. But if I do that, then I run into the situation where I can't use a single language. One trick that I tried for a while was to use a C++ build system where you have a very thin batch and shell script that build and run a C program, and then that C program does all of the actual build logic. That is possible, but it just turns out to be very tricky. It's kind of slows things down. C is a poor language for that kind of work. And it means that your build system is like this weird brittle thing that if you break it, then you start getting compilation errors in your build system itself. And if you haven't been careful, then you end up needing to like twiddle with the flags on that and with the flags in the final build. And it's very confusing. So I'm not a huge fan of that. So the trick I'm going to rely on instead is to use bash. And the reason this works is, first of all, on Linux and Mac, bash just works. There's a little bit we have to be careful about where there are small differences in what's available on Mac versus Linux. And when it comes time to deal with that, we'll be careful and we'll test to make sure we're doing everything right. But for the Linux Windows part, it turns out this actually works because if you have to install Git on Windows, which almost everyone, you always end up having to install Git sooner or later at this point. And once you have Git, you have a bash interpreter installed because that's how Git works. So if you have a Windows installation of Git, then you have a bash interpreter. You also happen to get one if you're on Windows 10 these days, as they've got a bunch of Linux stuff just built in. But, point is, you've got options for how to run a bash script from Windows now. So it turns out we actually kind of have a way, whether it's by using Git, which you have to install anyways most of the time, or something else that you might have on Windows, you tend to be able to run a bash script on Windows. So that works as a shared language between the two operating systems now. So that's why this whole thing is going to be written in bash. I'm not going to give a comprehensive bash script tutorial here, but I do want to stop and emphasize some of the more cryptic things that I'm using, the things that look weird and aren't immediately sort of intuitively readable to a programmer who has already learned a language or two. So that's what I'm going to do real quick. This example code is how the bash language has a built-in substring feature that'll let me chop up strings. And I'm going to show a couple ways that I'm using it here. So I have an example string with 2 dots in it, and then I'm using these substring expressions to chop it up in different ways. So if we take a look, the first 2 expressions will give me a prefix of the string, or to put it another way, they chop off the end of the string, and that's because they're based on the percent operators. And then the second 2 expressions give me a suffix of the main string, or to put it another way, they skip past the beginning of the string, and that's because they're the pound operator. Then when I use 2 operators, if I use 2% or if I use 2 pounds, then I get the smallest possible substring, right? So I'll get the smallest possible beginning of the string or smallest possible ending of the string based on how I'm chopping it up, right? And then if I use 1, I get the opposite. I get the largest possible substring, the largest possible prefix, or the largest possible suffix. So to recap, pound means I'm getting a suffix, percent means I'm getting a prefix, 2 means I'm getting the smallest possible, 1 means I'm getting the largest possible. Finally, to tell it what string I want to use to chop up, I have the period here in the expression, and then there's a star on one side or the other based on whether I'm doing prefixes or suffixes, because what's actually happening here is a little more complicated. The star is a wildcard, and it's matching with the string and the wildcard to figure out where the prefixes and suffixes are. But the thing is, I don't really want to combine lots of these complicated regular expressions in all these different ways. I'm happy with just having the ability to skip and chop parts of the string at certain delimiters, and so I'm only really going to use it in the way that's shown here. So I'm not going to try to explain how all the wildcard stuff works. I don't even fully remember it. I just use these patterns, so that's what I'm going to stick with in this script too. Another thing I'm doing in this script to make it work a little nicer is I'm making sure that whatever current working directory I am at when I run the scripts, that it kind of adjusts automatically to the layout of the code base so that it works no matter where I run it. I kind of find it annoying when I have to debug scripts not working because they can't find each other and they're just changing because, oh, in this case I was in the build folder and over there I was in the source folder or something. So to avoid that, what I do is I use this strange little expression here, which is just going to pull out the path of the build script itself and stick it into the variable, and then I'm going to walk around and grab all of the other paths in the code base that are relevant and sort of establish labels for them. So that's what these variables are doing. Speaking of relevant paths, another key concept of the system I should explain is the Loco Folder, which is a place where I'm going to hide files from Git, and it's going to be where I put things like parameters that control the build system. And the reason I use this folder for parameters is so that if I have multiple people on the same code base, then they can each sort of set up the parameters for building however they need to do for whatever they're working on without it getting synced up in the repo and colliding with everyone else. So it's sort of outside of the repo, but the code base knows that it's there and each person can configure it differently. Another thing that's useful about it is even in a single person scenario like the code base currently is, this hidden folder will mean that when I'm doing meaningless changes to the parameters, it won't show up in the Git history as constantly switching back and forth between this setup and that setup when there's no purpose for any of that information to actually be in the history. Because it's just configuration parameters that are, one of many ways that the code could be built during that state of the code base. In previous iterations of the system, what I did was I had a separate parameter for each of the sort of local context variables that I wanted the system to have. And then that script would echo out the value that that variable was supposed to have. So I'd have a compiler.sh script, for instance, in the local folder, and it would echo out the name of the compiler that it wanted to have to be used. I recently heard about a command in Bash that would allow me to tighten this up by loading a script into another script, essentially. So usually when you run one script from another script, the variables from the call e script don't show up in the caller script. But there's a command that I ended up finding called source that has the effect that when you use source to run a script, all the variables that that script sets up actually are available in the environment of the caller script. And this is great for me because in this case that I'll be able to set up all the variables inside of one single script now. So I'm going to have just this one single script inside my local folder that sets up all these context parameters. And then when I source that into the BLD core script, I'll just have them all ready to go and I won't have to call a bunch of individual scripts and read out their values. So it's just going to condense the system a little bit. It means there's less files and less lines of code to set the thing up. All right, so that's most of the sort of fundamental setup. I've got all the paths there. I've got I've showed how the substring stuff that we're going to use is going to work. All that kind of fundamental work is set up. So I think we'll stop here for now, and then we'll get a little farther into this system next time. See you then.